Hello, everyone. Welcome back to chapter 3.2, which is forms. Forms are one of the most important parts of a web page because they allow users to interact with the site. Whenever you fill out of a login page, submit a search query, or complete a sign up form, you are working with HTML forms. In this section, we will look at the basic building blocks of forms, the form element itself, along with input like text boxes, radio button, check boxes, drop downs, and buttons. We will also talk about how forms collect user data and send it to a server for processing. So, by the end of this section, you will have a good understanding of how to create forms that capture information from users and connect that information to your web page's functionality. Let's start with the form element itself, since that's the foundation of any web form. The form element is what allows a browser to collect information from the user and then send that information to a server. So, whenever we create text fields, buttons, or drop downs, they all sit inside a form. Now, two important attributes go along with it. The first is the action attribute. This tells the browser where to send the data. In other words, the URL of the server that's going to handle the form submission. The second is the method attribute. This tells the browser how to send the data. Usually that's done using an HTTP request type like get or post. Get is often used for simple requests like search queries where data is sent in the URL, and post, on the other hand, is used when we need to send more secure or larger amounts of data like login credentials. So when form element action and method define what the form does, where the data goes, and how it gets there. Now let's see how a form actually submits data to a server. For example, here we have a form element with an action set to https://example.com/apply and the method set to post. That means when the user fills out the form and clicks submit, the data will be sent to the URL using a post request. Inside the form, we are using a label tag and input tag element. The label provides a description like first name or last name, and the input creates the text box where the user usually um, types their information. Notice how the label uses the attribute to match the input's ID. This links the two together, which improves usability and accessibility. Finally, we have an input type equal to submit that creates the button the user clicks to send the data. So, in this case, when the submit button is pressed, the first name and last name typed into the form are bundled together and sent to the server. This shows how HTML forms act as the bridge between the user typing something into a page and the server receiving that information. Now, let's walk through what actually happens when a user submits a form. In this example, the user enters Sarah as the first name and Connor as the last name. Once they click the submit button, the browser takes that information and sends it to the server. On the server side, the submitted data isn't just received, it's usually stored in a database. You can see that after submission, Sarah Connor gets added to the existing list of names in the database. So the important flow here is the user types into the form, the browser sends the form data, and the server processes and stores it. This process is at the heart of most web applications, whether it's signing up, logging in, or even shopping online. So, when a browser stands from data to a server, there are different ways it can do it. One common way is called the get method. With the get method, when the user clicks the submit button, the browser collects all the form data and turns it into a query string. That's just a set of name equal to value pairs, with each pair separated by an ampersand, and the browser then attach this query string to the end of the URL right after a question mark. So for example, if the user typed in their first and last name, the URL might look like http example.com/apply question mark first equal to Sarah and last equal to Connor. So this URL is then sent to the server at an HTTP GET request, and the server sends back a response to update or reload the page. Because the form data is visible in the URL, the GET method should only be used for simple, not sensitive data like search terms. It should not be used for private information such as phone numbers or credit card details. Let's look at an example of how the get method works in practice. Here, the user fills in the form with their first name Rick and last name Deckard. Once the submit button is clicked, the browser collects these values and creates what we call a query string. In this case, first equal to Rick and last equal to Deckard. This query string is then attached to the form's action URL. So the final URL becomes something like this. The browser uses this new URL to send a GET request to the server. The browser processes the request and responds with a new web page. Notice how the form data, the name Rick and Deckard, are right there in the URL. That makes GET very transparent and easy to use for things like search or filtering, but it's also a reminder why GET is not suited for private information. Now that we have seen how GET works, let's look into another common way to send from form data, the POST method. With POST, the process starts with the same way. The user fills in the form and clicks the submit button. The browser then prepares a HTTP POST request using the URL formed from the form's action attribute. Next, the browser takes the form data, for example, first equal to Sarah and last equal to Connor. But instead of putting it into the URL like get, post places this information in the body of request message. That means the data is not visible in the address bar. The request is then sent to the server, which processes the information and responds with a new or updated web page. So the key difference is this: get shows the data in the URL while post keeps the data hidden in the request body. That makes post better for sensitive informations like password, phone numbers, or credit card details. Here is an example of how Post looks in action using Chrome DevTools. On the left side, we see the web page with the form. The user has typed Sarah as the first name and Connor as the last name. The form is set up to send this information to a URL using the post method. Once the user presses the submit button, the browser sends the data to the server, but instead of putting it in the URL like get, it places the information in the request body. On the right side, DevTool is showing us the detail of that HTTP request. If we look under the payload tab, we can clearly see the form data written as the first equal to Sarah and last equal to Connor. This confirms how post works. The values are sent securely in the request body, not visible in the URL bar, but still accessible to the server for processing it. Up to now, we have seen forms that just send plain data texts like names or search queries, but what happens if we need to send something larger, like a file or an image? In those cases, the normal query string format is not enough because binary data cannot be properly represented in a simple name equal to value pair. To handle this, HTML forms use the ink type attribute. When the post value is set to multi-part or form data, the browser takes the post request and splits into multiple parts. Each input field is sent as its own part of the request body. This way text fields are sent normally, but files and images are properly packaged and sent alongside them. You will often see multi-part or form data used in upload forms, like when you are submitting a profile picture or attaching a document. Here is an example of how the ink type attribute works in action, where the user enters their first and last name, which is Rick Deckard, and also selects an image to upload. When the user presses submit, the browser needs to send both text and binary image data to server. Instead of combining everything into a single query string, the browser breaks the data onto multiple parts. Each part is sent separately within the post request, so the names go into one part while the image is placed in another. On the right, you can see how the request is packaged. First, equal to Rick and last equal to Deckard are plain text fields, while the picture is attached as a separate data block. This is the role of multi-part form data. It allows us to send text files and text fields and different files together, making it essential for file uploads like image, documents, or videos. Now let's look at something very important where when working with form data, skipping special characters. In a query string, certain characters like um, and or question mark and already have special meanings. For example, and is used to separate different names equal to value pairs, and um, equal sign is used to assign different values. So if a user types this symbol directly into a form, the browser won't know whether they are part of the data or part of the query structure. So to fix this, the browser skips these characters, which means it transforms them into a safe representation. Here are the rules. The spaces are turned into the plus sign. All other reserved characters as well as new line and tabs are replaced with the percent sign and XX, where XX is the ASCII hex code for the character. For example, if the user types 1 plus 2 equal to what into a text box, the browser escapes it as 1 plus percentage 2b plus 2 plus percentage 3d plus percentage 3f. Here, percentage 2b is the hex code for plus sign, and percentage 3d is the hex code for equal sign, and percentage 3f is the code for the question mark. So skipping ensures that the form data is transmitted correctly without breaking the structure of the query setting. Now that we have seen how forms work, let's talk about the building blocks inside them. The forms widget. A widget is basically an interactive components on a web page that allows the user to input or select information. Think of things like text boxes, buttons, or drop-down menus. All of these are widgets in HTML. The most common way to create widgets is with the input element. This tag is very flexible and can generate different kind of widget depending on the type attribute you give it. For example, type equal to text creates a text field, type equal to password hides the characters that you type, and type equal to submit creates a button that sends the form. Another important attribute is the name attribute. this name the widget, and when the form is submitted, the browser sends the widget value paired with the name of the server. For example, if you have name equal to username, the form submission will include username equal to the value entered. So in short, widgets are how users interact with forms, and the input element, along with its attribute, is at the core of creating those interactions. Now let's go a little deeper into form widgets and some of their useful attributes. First, we have the ID attribute. This gives a widget a unique identifier within the web page. It's especially helpful when you want to link a label to an input or when you are styling or scripting with CSS and JavaScript. Next is the placeholder attribute. This is the faint text you often see inside a text box before typing. It acts as a hint guiding users on what kind of information to enter. For example, enter your email, and then we have the value attributes. This sets a default value for the widget. For a text box, it might show pre-filled text. For a button, the value usually becomes the text displayed on the button. Now let's talk about two common widget types. First, the text box created with input type equal to text allows the user to enter a single line of text such as their name or email. A submit button created with input type equal to submit generates a clickable button. When pressed, it collects all the form data and sends it to the server, following the rules of the form's action and method. So these attributes and widget type give us control over both how the input looks and how it behaves when the form is submitted. Now here we have an example of an HTML form that sends a status update using a secure HTTP post request. In this case, the form asks the user to type in a short message, something like a tweet. Notice that the text box widget doesn't use a value attribute because it wouldn't make sense to have a default tweet already filled in. Instead, it uses a placeholder which gives a hint to the user with the text, for example, your status. Now, for the submit button, you will see it doesn't include a name attribute. That's because the server doesn't really need the value of the button itself. The button's only job is to trigger the form submission. The important data comes from the input fields like the text box. So when the user types in a message and clicks send status, the browser packages up the message and sends it to the server securely using POST. Now let's talk about label and how they work with the form elements. The label tag is used to display descriptive text for a specific widget. In this example, the word username is a label that's tied to the text box beside it. What makes this connection work is the for attribute. The labels for value must match the ID of the widget it's describing. So here the label has for equal username and the input field has ID equal to username. This way they are linked together. One nice benefit of this connection is accessibility. For example, if a screen reader is being used, it will read out the label when the input box is forced. Also, clicking directly on the label text will automatically place the cursor inside the input field, making the form relatively easier to use. So up to now, we have mostly looked into text boxes, which only allow a single line of input. But what if we need to collect a longer response, like feedback or a description or a comment? That's where the text area element comes in. The text area tag creates a text area widget that lets user enter multiple lines of text. You will notice here in the example, it starts with text area and ends with with a closing tag, unlike the input element, which is self-closing. We can also control the size of this box with attributes like rows and columns. In this example, the text area has rows equal to 4 and columns equal to 50. So the box appears as 4 lines tall and about 50 characters wide. The important part is that a text area grows as you type, allowing users to provide more detailed input than a single line box would allow. So that's all about forms, and I will see you guys in chapter 3.3.